We're going to spend a few minutes reviewing measuring with instruments that we'd use in science, like meter sticks and graduated cylinders and things like that. So let's start with measuring with something like a meter stick. So if you look at this light blue rectangle that's here, this one, this is representing a meter stick. Each one of the larger marks represents one of those centimeter marks that's on there, and obviously this is just a small segment. Each one of the smaller marks in between represents a millimeter marking. So every one of those lines will allow us to know exactly how many millimeters or tenths of a centimeter our measurement is. But what you need to understand is that last measurement should be estimated. So when I look at this, the darker blue shape that I am measuring here, this one, comes to this point right here. Now if I look at that, I can see that it is exactly, well, it's not exactly, it's between 12.7 and 12.8 centimeters. So remember, the big mark is the centimeter, the little one's a tenth of a centimeter, or what we call a millimeter. So 12.1 would be this one, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Now, this darker blue shape goes past 12.7 centimeters, but it's not quite 12.8, so we have to estimate that in between. So we're estimating that it's 12.72 centimeters, and that's where this number right here is coming from. So in science, sometimes we use a graduated cylinder, a device like this, to measure volume of a liquid. When we do that, we have to read what we call the meniscus. The meniscus is, if you look at the surface of the liquid, it kind of curves. That's the meniscus. The bottom right here is where we're going to read. So if we look at this up-close view of the graduated cylinder, we can see this is somewhere between 40 and 50, and our unit is milliliters. Now if I look at this, if this is 40 to 50, and each one of these little marks must be a tenth of a milliliter, because there are 10 of them there. So I'm going to estimate that this is around 40.1, 2, 3, and I'd actually estimate, so I know it's 40.3, it looks like it's exactly 40.3, so we can actually say that it is 40.30 milliliters. So that's how we'd read that graduated cylinder. If we look at the balance that's over here, obviously we just put everything on it. We make sure that this number right here says 0 before there's anything on there to mass. And then when you read it, you have to make sure that you record all of the numbers or the digits that are on there. And this one looks like it's in grams, so it's 45.22 grams. And we understand now that this last number is estimated. All right, last one we have here is our centimeters again. We don't know if this is a ruler or a meter stick, but either way we're measuring length. We know the unit is centimeter. This oval or ellipse that's in here looks like it starts right at the 0, and that's really important when you're measuring length of an object. Make sure that whatever the edge is starts right there at that 0, because there are times when your ruler, the 0 is in from the edge, and sometimes it's on the edge, so you have to pay attention to that. So we have our item lined up with the 0. We're going to measure the length, and it goes out here to, this looks like it's 2.9. Now if you look really, really close right there, it looks like it's just before the 9. So we're going to estimate that at, let's see, 2.9, and then we're going to have to put that estimated digit of maybe 0. Maybe you're looking at it and you're thinking it's 2.89, and that's okay. Again, that last digit is estimated. So that would be our measurement there. And again, that unit is centimeters. All right, when we're talking about measurement, the measurement units that we're going to use obviously depends on what we're measuring. So if we're measuring something like length, our SI unit's going to be meter. Now it could be kilometer, centimeter, things like that, but this is the base unit for the SI unit. Volume, we're going to use cubic meter, and that should be a superscript 3. Mass, our SI unit is kilogram, unit symbol is kg. Density, you could see gram per cubic meter or gram per milliliter. temperature, the SI unit is Kelvin, but we're more familiar probably with Celsius degrees. All right, time we'll measure with seconds. Now these are just base units. We can put prefixes in front if we need to. Things that you may not see anytime soon, maybe not till you get into chemistry or physics, but we have pressure measured with pascals, energy with joules, and amount of a substance is a mole. Don't worry too much about these three that are here on the bottom, right here. We're not real worried about those, but you should be pretty aware of these ones on the top down here to time. Some of the commonly used prefixes that you're going to see in front of units like meter or gram or liter or second would be these that are listed here. Mega is, if you see a mega, capital M in front of something, a base unit, that means 1 million. So a megameter would be 1,000,000 meters. If you see kilo in front of meter or liter, that means there's 1,000 meters or liters in a kilometer. Deci is a tenth, so a decimeter is a tenth of a meter. Centi, centimeter, centigram, centiliter, that's 100th of a meter or a liter or a gram or whatever it's in front of. Milli is a thousandth, sorry. A milli is a thousandth, so it takes 1,000 of these to equal whatever the base unit is. And then if you're talking about something really, really small, you might see micro, nano, or pico. Another measurement that we talk about is density. Now, density for any substance is always going to be the same. The density of lead will always be the same if it's all lead. It's a ratio of mass to volume. So if you increase the mass of the substance, you're going to also increase the volume. Likewise, if you increase the volume of something, you're going to increase the mass. So when you do that, that ratio will always, always, always be the same. For example, water's density is always 1 gram per cubic centimeter. So when you see water's density, 1.0 grams per cubic centimeter, or or milliliter, what we have here is the mass unit is gram, the volume unit is cubic centimeter, so it's mass over volume, mass over volume. No matter how much water I have, the density will always remain the same as long as it's pure water. And that's true for every substance. It's just a ratio of mass to volume. So we talked a little bit about temperature, and when we did, we mentioned the Kelvin scale. We also talked that Celsius is a little bit more, maybe more common for us. But the Kelvin scale is what we use for the SI unit, and that's where we get the term absolute zero, because 0 Kelvin, 0 degrees Kelvin, is equal to absolute zero. It's the lowest possible temperature. You can never have a negative Kelvin temperature. Now to get from Celsius to Kelvin or Kelvin to Celsius, all we have to do is add or subtract, and that's because a degree in Kelvin is equal to a degree in Celsius, or that change in temperature. And it's technically not a degree in Kelvin, it's just 0 Kelvin. Now keep in mind, 0 Kelvin is the lowest possible temperature. 0 degrees Celsius is definitely not, that is freezing point. So if I had the temperature, our freezing point, 0 degrees Celsius, and I wanted to figure out what that is in Kelvin, I would use this conversion right here, and all I'd have to do is add 273 to get the Kelvin temperature, and that would be 273 Kelvin. So 0 Celsius and 273 Kelvin are the same temperature. If you're still struggling with measurement and measuring or the metric system, please come see me for some help.